Okay, so this is from a request from Poppy, who just wanted me to go over a couple of the harder questions on the Hegarty number 300 on those reciprocal graphs. So this is just going to quickly be going over questions 4 and questions 5. Now, when you're trying to find the vertical asymptote, so that's going to be the asymptote going downwards, something like that. You get the asymptote going downwards when the number just doesn't exist. Okay, it's just not possible. Now, if you go and get your calculator out and you go and do any number divided by naught, you get error. Okay, any number divided by naught, you get error. So what we're really saying in a question like this is what value is going to make the denominator equal to naught? Because 1 divided by naught does not exist. So clearly, how do we make x plus 4 equaling naught? That is when x equals minus 4. Okay, so the value x equals minus 4 is the answer. Okay, Poppy, does that make sense?
Yeah, it does.
Yeah. Right, and I'm just suddenly had a thought about something that Ivy was saying, that so you just had to put in the value minus 4, didn't you? You didn't have to just write in x equals minus 4, or
maybe... Well, one of them I guessed it, but then I think you did as well.
Yeah, I think I made the wrong comment when I got back to
But I didn't get the numbers right.
No,
anyway,
I am
so
right.
Kind of
so
irrelevant.
the question says, what is the equation of the vertical asymptote? No, I am right. So the question doesn't say what value of x it doesn't work for. The question is asking for the equation of the vertical asymptote. So for this particular question, the vertical asymptote is there, and the name of that line, like I said to Ivy, is x equals minus 4. Okay, so I think Ivy answered it thinking the question said what value of x doesn't exist, and that is x being equal to minus 4. But to answer the question, what is the equation of the vertical asymptote? That is x equals minus 4. Now, does that make sense, Poppy?
No. Yeah, it does.
It does. Okay. Now, that's how you get the vertical asymptote. The one going straight down is what value of x makes the denominator equal to 0. Now, on the other hand, for horizontal asymptotes, what we're saying is to get a horizontal asymptote. So this isn't the one for this question, but just to give you an example, that would be a horizontal asymptote. And that is where the curve is getting closer and closer and closer and closer to get it, but never actually reaches it. So just think about this question here, okay? Y equaling 1 over x. So as x gets massive, as x gets massive, it gets bigger and bigger and bigger. When x gets massive, let's say 1 over that, that is one hell of a very, very small number. You know, it's 0.0000000 whatever with a 1 on the end. So what are we approaching? We're getting very close. We're getting closer and closer and closer, but we'll never actually get there. The asymptote is actually the x-axis. The asymptote is the x-axis. That we're getting closer and closer and closer to naught, but we never quite get there. So the correct answer is the x-axis, which is the equation of the x-axis is y equaling naught. Okay, so that does that make sense, Poppy? Or Poppy, have you gone? Right, Poppy might have had to go. I know she was having a one-to-ones today. So in short, we're saying the horizontal asymptotes are where you're getting closer and closer and closer to a number, and you can see here as x gets bigger and bigger and bigger, we're approaching 0. So the asymptote, the equation of the horizontal asymptote is y equals naught, whereas for the vertical asymptotes, the vertical asymptote happens where it just does not exist. So where does the denominator equal 0? So I hope that's helped clarify things a bit. Bye.